Viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve a problem asked in CSIR NET June 2011 in part C. This question is related to integral equations. So here we are given the integral equation f of x equal to cos 2x plus lambda times integral 0 to pi cos of x plus t dt. So we need to check under what values of lambda this equation has unique solution or no solution or infinite number of solutions. So for this we need to find the eigenvalues first. So the eigenvalues are given by the equation d of lambda equal to 0. So d of lambda, d of lambda is equal to 1 minus the equation a11 into lambda minus a21 lambda equation. So we will write for 2 by 2 minus, this will be a12 lambda, and this will be minus a21 lambda. This one is 1 minus a22 lambda. So determinant of this one. So from the given integral equation we can find the kernel. So this kernel is k of x comma t. Okay, so given that given k of x comma t equal to cos of x plus t. So this can be explained as, so using the formula of cos a plus b, this is cos a cos b minus sin a sin b. So this is k of x comma t. So this type of kernel we call it as separable kernel because each term of this kernel is a product of x term and product of y t term. So therefore we can take this as a1, this one is b1, this is a2, and this is b2. So now we will see the formula of aij. It is a11, so that is a11. So a11 equal to integral, so this is the limit, so limit is from 0 to pi, so therefore integral 0 to pi a1 of t into b1 of t dt. So a1 of t is cos t, b1 of t is cos t, so therefore is equal to cos square t, integral 0 to pi cos square t dt. So cos square t can be written as 1 plus cos 2t by 2 dt. So now we can integrate this one. So this is equal to 1 by 2 integral, so we will integrate. So the limit is 0 to pi, so this will be t plus sin 2t by 2, so the limit is 0 to pi, so this is equal to 1 by 2 upper limit pi sin 2 pi is 0 minus lower limit 0 sin 0 is 0, so therefore get pi by 2. And similarly we can find a22. A22 is equal to integral 0 to pi a2 of t into b2 of t. So this is equal to integral 0 to pi a2 is sin x, b2 is sin t, so therefore sin square t dt. This is equal to integral 0 to pi, so 1 minus cos 2t by 2 to dt. So this is equal to 1 by 2 integrating this t minus sine 2t by 2. So the limit is 0 to pi. So the answer will be similar as A11. So because there is no contribution from this term sine 2t by 2, so we'll get 1 by 2 pi is pi by 2. So this is A22, and A12 is integral 0 to pi A2 of t into B1 of t dt. So this is equal to integral 0 to pi A2 of t, this one A2 of t is sin t, and B1 of t, B1 of t is cos t dt. So this is equal to integral 0 to pi. So this can be written as 1 by 2 sin 2t dt. So when we integrate 1 by 2 minus cos 2t by 2, so the limit is 0 to pi. So this is equal to minus 1 by 4 cos 2 pi minus cos 0. So this will be 1 minus 1. So this is equal to 0. And similarly A21 will also be 0. So you can check this one. So the steps will be similar, same as A12. Now d of lambda. So d of lambda is equal to 1 minus A11. So A11 is pi by 2 and A22 is also pi by 2. So 1 minus pi by 2 lambda, and A21 is 0, A12 is 0, A21 is 0, and this is also 1 minus. So we'll see A22. So A22 will be having on negative sign because of this minus. So this is minus sine square t and minus minus, so minus minus. So this will be 1 plus pi by 2 lambda. Now d of lambda equal to 0. This implies 1 minus pi by 2 lambda into 1 plus pi by 2 lambda equal to 0. So lambda is equal to 2 by pi in this case, and here lambda is equal to minus 2 by pi. So these are the values of lambda. It's called eigenvalues. So now this integral equation has unique solution when this determinant is not equal to 0. That is unique solution when lambda not equal to 2 by pi and lambda not equal to minus 2 by pi. Now if d of lambda equal to 0, this integral equation may have no solution or infinite number of solutions. So we will deal the cases separately. So let us take so d of lambda equal to 0 means we get lambda is equal to 2 by pi and lambda is equal to minus 2 by pi. So first we will consider the case when lambda is equal to 2 by pi. So when lambda is equal to 2 by pi, so we have to find the equation. So the equation we can find it by calculating f1 and f2. so that we will calculate f1. So f1 is calculated by using the formula integral 0 to pi so this is a non-homogeneous term, so this one cos 2x correction, so this is cos x, not cos 2x, cos x. This is f of t, so f of t is cos t into b1. So b1 of t is cos t. So this is equal to 0 to pi cos square t dt. Again we can use the formula 1 plus cos 2t by 2, so that we have already evaluated. So this is equal to pi by 2. And for f2 it is 0 to pi cos t into b2. So this b2 is sin t. Okay, so b2 is sin t dt. So this is same as a12 or a21, so this answer is 0. So therefore the two equations are you can write the two equations. So 1 minus a11 lambda into c1 plus minus a22 lambda into c2, so this is equal to f1, and this one is c1, sorry, minus a21 minus a21 lambda into c1 minus plus 1 minus a22 lambda into c2 equal to f2. These are two equations. So already we have find out a11 and f1, f2. So just substitute here. So now we will take the cases. So first we will consider the case when a lambda is equal to 2 by pi. So lambda is equal to 2 by pi, this implies 1 minus, so a11, so a11 is pi by 2 already, pi by 2, c1, so this is 0, so equal to f1, so f1 is pi by 2. And second equation, so this is 0 plus 1 minus a22 is minus pi by 2, so 1 plus pi by 2, c2 equal to 0. So now this implies, so this is equal to lambda. Now substituting the lambda is equal to 2 by pi, so 1 minus pi by 2 into 2 by pi into c1 equal to pi by 2. So this is 2 to pi. So 1 minus 1 0, so 0 into c1 equal to pi by 2, that is pi by 2 equal to 0, so this is wrong. So therefore, so this implies lambda equal to 2 by pi gives no solution. So next you will see the case what happens when lambda is equal to minus 2 by pi. lambda is equal to minus 2 by pi, this equation 1 and equation 2 place 1 minus pi by 2 into minus 2 by pi into C1 equal to pi by 2. So again these two will get cancelled. So 1, 2, 2C1 equal to pi by 2. So this implies C1 equal to pi by 4. So next we will take the second equation. Second equation is 1 plus 2 by pi, 1 plus pi by 2, 1 plus pi by 2 into minus 2 by pi, C2 equal to 0. So again we can cancel this one. So 1 minus 1, 0. So therefore 0 equal to 0. So both sides are satisfied. So this implies lambda is equal to minus 2 by pi gives infinite number of solutions. So now we will check the options one by one. So unique solution if lambda equal to 1 and an infinite number of solution if lambda is equal to 2 by pi. So here when lambda is equal to 2 by pi, so we get no solution. So therefore the first option is wrong. And unique solution when lambda is equal to minus 1 and infinite number of solution if lambda is equal to minus 2 by pi. So this one lambda is equal to minus 2 by pi gives infinite number of solution. And now so this one as unique solution when d of lambda is not equal to 0. When lambda is equal to 1, so 1 is not equal to 2 by pi. So therefore this gives unique solution. Lambda is equal to both lambda is equal to minus 1 gives unique solution and also lambda is equal to 1 gives unique solution. So this is correct. A unique solution, so when lambda is not equal to 2 by pi, so when lambda is not equal to 2 by pi it gives unique solution, but we should have one more condition, lambda not equal to minus 2 by pi. So this is wrong and this is also wrong. So no solution if lambda is equal to plus or minus 2 by pi because we have infinite number solution when lambda is equal to minus 2 by pi. Okay. So the only correct option for this question is option B. Okay. So this is a part C question, but it has only one correct answer. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.